Hi everyone. I want to take a moment to discuss the transportation method that's found in chapter 13 that looks at various supply chain logistic network type of problems. Okay. Now the transportation method that's found in chapter 13 looks at situations where you have multiple supply side locations and you might have multiple demand side locations, right? So an example of this would be, say, a distribution network where you might have, and let me bring out my pencil here, you might have facilities located in, say, 3 different locations. And you might have customers located in some other locations, and you're trying to figure out how can we move product from these supply locations. Okay, if we have, say, this 3 supply locations and we need to move product from those 3 supply locations, which could be warehouses, it could be distribution centers, to these customer locations. So it could be moving stuff from a distribution center or distribution centers to retail outlets, or it could be stuff moving from some distribution centers directly to customers at some other locations, right? Now, given that we have 3 supply sources here, 1, 2, and 3, one question that the logistics manager or the logistics planner has to figure out is, where should we ship product to? If we have product in 3 locations here, and we have customers in 3 different locations as well, A, B, and C. Okay, so the question that we are seeking to answer here is, for example, which of these 3 houses should we ship product to B from, right? So, and which of these 3 warehouses should we ship product to A from, and so on and so forth. Okay, so each transportation style problem will always have your supply side sources and your demand side destination. Okay, now we have to also have information associated with how much does it cost for us to move product from those supply side locations to the different demand side location. Okay, and that's usually found on a table that enables you to figure out how much would it cost to move product. The other thing that we need to know is how much product do we have sitting in each and every one of those supply side locations. Okay, and we also need to know how much do the customers need at those demand side locations. Okay, so a transportation method problem is usually presented to you in this type of format. Okay, and this format here shows, in this case here, we have 2 plants. So we have product that can ship from either Phoenix, or we can have product shipping from Atlanta. Okay, Phoenix has a capacity of 400 units. Atlanta has a capacity of 500 units. Okay, so the maximum that can ship out of Atlanta is 500 units. The maximum that can ship out of Phoenix would be 400 units. Okay, now they need to ship product to San Antonio, Texas, to Hot Springs, Arkansas, and to Sioux Falls, South Dakota. And we're told how much exactly it costs to ship. So shipping from Phoenix to San Antonio is going to cost us $5. Shipping from Phoenix to Hot Springs is going to cost us $6 per load, if that's the case. And then shipping from Phoenix to Sioux Falls, South Dakota would cost us $5.40. Okay, and the same would apply to Atlanta. The cost to ship from Atlanta to San Antonio is $7. Atlanta to Hot Springs would be $4.60, and Atlanta to Sioux Falls would be $6.60. Okay, the last thing that we have here is information with regards to the demand at those warehouses, and the demand here shows that San Antonio needs 200 units, Hot Springs needs 400 units, and Sioux Falls requires 300 units. Okay, so we have all the information we need to figure out what's the lowest possible cost combination that we can have in terms of what can we ship out of Phoenix and what can we ship out of Atlanta to these 3 destinations. Okay, now how I want you to approach any problem that looks like this is to take this information, possibly put it in an Excel spreadsheet, which I already have here. Okay, exact same information that's on the PowerPoint from the chapter, I've posted it here. Now, I want you to follow a systematic three-step approach to finding a solution to this. So the first thing I need to do is figure out what are my decision variables. Second thing I need to do is determine what's my objective or my objective function. And the last thing that I need to do is figure out, are there any constraints to this decision? Okay. Now your decision variables here, basically what is it that you need to figure out to be able to calculate cost? And in this case here, we have parameters, we have information on how much it costs for the moves. What I don't have information on is how much is going to move between the plants and the different warehouses. Okay, so a decision variable will be basically how much is going to move between these two plants and these three warehouses. Okay, so I'll keep that in mind, and I'll go to, and for the purposes of calculating this, I'm going to copy this table and paste it. So I'll have two tables that look pretty similar. Copy, paste, and now I'll delete the values I have here. Okay, and the reason why I'm doing that is I want Excel to give me the solutions to how much are we going to ship between Phoenix and San Antonio, Phoenix to Sioux Falls, Phoenix to Hot Springs, and the same for Atlanta. Okay, so these cells I've highlighted in yellow here are decision variables. We just leave them blank because we don't know what it's going to be until we finish our calculation. Next, I'm going to calculate what we call our objective function. Okay, whenever you have a transportation problem, because transportation involves cost, your objective is to try and minimize that cost. Okay, so I know there's going to be around 6 different moves here, and I want to make sure I'm sending product along the shortest path. So maybe I'll send some product from Phoenix to Hot Springs, Phoenix to San Antonio. It all depends on which will give us the least possible cost. Okay, now how do we calculate cost? Cost is going to be a function of these costs here per ton multiplied by however many tons we move. Okay, now notice we don't have information on how many tons we're moving here. We just know that it's we have the cost to move a ton, but we don't have the total tons here. But I know that San Antonio requires 200 tons. I don't know whether it's going to come from Phoenix or whether it's going to come from Atlanta. Hot Springs requires 400 tons, and Sioux Falls requires 300 tons. Okay, so I'm going to put a cell here that I'm going to call my objective function. And I'm going to put a formula here that's basically going to multiply the cost to move 1 ton by the total tons moved. So once we solve this, solver is going to, we're going to use solver here, and it's going to give us some numbers here. Maybe 400, whatever those numbers would be. Okay, so I'm going to multiply, sorry, these are not costs, these are tonnage. Okay, so I'm going to multiply the cost to move product from Phoenix to San Antonio by the weight that we move between Phoenix and San Antonio. And I want to do that in this cell right here. So let me highlight that here. Now, the two ways of doing it, you could do it the harder way, which would be 5 multiplied by 450 plus 6 multiplied by 400, and so on and so forth, and add them all up. Or you could use a function in Excel called the sum product and multiply these 6 costs here, comma, by these 6 blank spaces down here. Okay, I'm going to leave this blank because we don't have that information just yet. Okay, so this objective function is going to tell us what our total cost will be. So I'm done with the first two. I've put my decision variables in yellow. Let me change this to a different color. My objective function, let's put that in green. The last thing I need to know is what are my constraints to this model. Okay, now you're going to have what I call supply side constraints, which refer to how much can those two plants actually supply your customers. Okay, and in this case here, the maximum that they can supply is 400 and 500. Okay, Those are your supply side constraints. Okay. Then you also have your demand side constraints, which tells you how much your customers need. So we need San Antonio requires 200 tons, Hot Springs 400 tons, and Sioux Falls would be 300 tons. Okay, so I need to ensure that everything that is demanded by the customers can be shipped by the warehouse. Okay, so how do I check that? I check what's our total capacity from Phoenix and Atlanta. That's 400 plus 500 here. That's 900 tons. And how much do our customers need in total? That's 200 plus 400 plus 300, which is 900 as well. So this is what we call a balance problem. We have the capacity from the plant exactly matches the capacity requirement, the supply demand side requirements for these three warehouses. Okay, I'll need that when I'll be solving this using Solver. But I need to add two additional equations here, which are very simple. My first supply side equation here is going to be how much do we ship from Phoenix? And we're going to ship maybe around 400 units. I know it's going to be 400 because we have the exact same amount of capacity as is demanded by the customers. But the amount that's going to ship from Phoenix is going to be the amount that ships from Phoenix to San Antonio, plus the amount that ships from Phoenix to Hot Springs, plus the amount that ships from Phoenix to Sioux Falls. Okay, still don't know what that's going to be, but I'm just going to leave the formula there. I'll do the same for Atlanta and say that the amount that's going to ship out of Atlanta is whatever is received in those three locations. So sum those up. Okay, now coming to the demand side, I'll also have to ask myself, what's the total amount that's going to be received into San Antonio? And that'll be a function of what was shipped out of Phoenix plus what was shipped out of Atlanta to San Antonio. Okay, and drag this formula across. So now we have formulas for our amounts shipped and our amounts received. Okay. All right. Now we can go into Solver and try and solve this, which is the easy part. Okay. So in Solver, before I go into Solver, you might not have Solver on your first check to see if you have Solver. You go to Data, and you should see Solver on your far right-hand side of your screen. If you don't see Solver, then you need to install it. It's inbuilt. You just have to go to File, Options, Add-ins, and then click on the Analysis Tool Pack. The Solver add-in, and then click on Go. At this point, I usually say if you have the Analysis Tool Pack there, you could add it now so that if ever you need it in the future, you're going to have it. But for the purposes of this question, I'm more interested in the Solver add-in. So make sure that that is checked, and then click on OK. And if you do that, it should now pop up in the Analyze function of Excel. Okay, now let's go ahead and solve this in Excel. So if you click on Solver, it's going to ask you, what's your objective function cell? Where did you have that formula for your objective? And this is where I had my objective function right here. Click on the cell. And my objective, because it's a transportation cost problem, I want to minimize costs. And I'm going to minimize that by some combination of these decision variable cells here. So I'm just going to have Solver change these 6 cells here. This is what's going to calculate everything else. Okay. The one part that's our unknown, and that's what's going to enable us to calculate this. Now, the last part was what are our constraints? Our first constraint is that the total amount shipped, these two values here, I highlight both cells, should equal the total capacity in Phoenix as well as Atlanta. Okay, there are times when the capacity does not match the requirements. In this case here, the capacity was 900, the requirements was 900, I use an equal sign. If the capacity is greater than the amounts demanded, then I might have to use a less than or equal to sign and not an equal sign. Okay, so let's add our second constraint, which was that the amounts received into San Antonio, Hot Springs, and Sioux Falls should be equal to these three values here. Okay, we have 900 tons coming in, 900 tons that are demanded, so we use the equal sign. Okay, and then the last thing I'll do is make sure that I'm using the Simplex LP solving method and that my unconstrained variables are non-negative. Okay, we don't want to have a negative solution. We don't have negative amounts being shipped unless that's like a return, which is really not something we're interested in right now. So we solve and come up with a solution. Okay, so the solution you have here should be the lowest possible cost that you're going to have for the information that you're provided with here. Okay, and in the area in yellow, which are decision variables, we are now able to assess and see what does this tell us. It tells us that Phoenix had 400 tons, a capacity of 400 tons, shipped 200 to San Antonio, 200 to Sioux Falls, nothing to Hot Springs. For Atlanta, ship nothing to San Antonio, ship 400 tons to Hot Springs and 100 tons to Sioux Falls, South Dakota. Okay, so that satisfies the capacity here, and it also satisfies how much those customers required here. Okay, at the least possible cost. Okay, so that's how you'd put together your transportation related problem. Now, I mentioned that sometimes there might be a difference between the capacity here and the requirements here. Okay, if you had a question where the demand here, say here we had 400 as well. Let me get my formula back in. Say the requirements here was 400. Okay, now the total requirement for these three warehouses will end up being 1100, but we only have 900 units to ship. So we have an imbalance here. If you have an imbalance, then you have to tweak your solver dialog a little bit just to ensure that you can't ship what you don't have, right? So the maximum that's going to ship will have to be what's available at the plants, which is 900 units, which means we're not going to satisfy the last 200 tons of product that's required. So I'll go back into solver, and that's a constraint change. So I'll look at these constraints here and see what makes sense. We had 900 units in Phoenix and Atlanta. Because that's less than what's demanded by the customer, let's ship everything that's there. So this stays the same. Sorry, this right here stays the same. But when it comes to the receiving side, we're going to tweak this a little bit. Okay, so we're going to change and say that in this case here, this will have to be less than or equal to, because we're not going to be able to satisfy all the customer requirements. So we might have to receive slightly less than we needed, and that's the only change you'd have to make here. Okay. Now, when you do that, you notice now that it tells us let's ship everything out of Phoenix to San Antonio, 400 tons to Hot Springs from Atlanta, and 100 tons to Sioux Falls, South Dakota. Okay, so we satisfy the requirement that everything that's in Phoenix and Atlanta has to ship out, but we have a net in our requirements here. Okay, and the net is right here. Sioux Falls, South Dakota is not going to receive everything that's required. Okay, it's going to receive 200 tons less than what it wanted. Okay, again, this is done at the least possible cost of $4,500, given the information that we have. Okay, so that's your typical transportation problem. I just wanted to share this, and you can use that to try and pretty much solve any transportation problem that you might have out there. Okay, thank you. That's all I have to share for right now.